Okay, let's do the second part. So we did FTC part 1 for 2 days. We're now going to do FTC part 2, which is that WSQ you watched. Okay, FTC part 2 says the integral from a to b of f of x dx is just the same as the function after you actually take the integral of b minus the function of a. So I'm just going to show you graphically what this actually means. Okay, the integral from a to b of f of x. And we talked about that in FTC number 1. We're saying that that is just a area function, right? That's just the area under the curve of f of x from a to b. So basically the area from a to b. Now, the integral of a function can be an area function, which is what this big F is. That's an area function of x. Now, if you think about it, f of b is really just this area, right? From whatever constant, let's say 0, to b, right? It's the area underneath the curve from 0 to b, or whatever constant to b. It really doesn't matter. Okay? F of a is just the area underneath the curve from 0 to a. They have the same starting point. So then f of b minus f of a is just the blue minus the red. So the leftover is this part, which is what we wanted anyways. The area from a to b underneath the graph f. Does that make sense? So it's just this big area minus the small area, which is the leftover area. And that's why this FTC part 2 works. Okay, so now let's go ahead and actually solve problems. So this is very useful because from now on, this is how you're going to evaluate all of your integrals. All right, this is the WSQ. Integral from 2 to a of f of t dt. And then most of you guys got this right? So basically, this is the integral of this is just f of t. And this is the notation. This is how people write integral. So they would say f of t is the actual function. We are evaluating. Evaluating is the straight line from from 2 to a. And then we always take the top minus the bottom. So this is going to be f of a minus f of 2. All right, let's do another one, number 2. Okay, so integral from 1 to 3 of e to the x. So what you want to do is evaluate the integral first. Find the integral first. So what is the integral of e to the x? E to the x is just e to the x. So it's e to the x. You want to evaluate from 1 to 3. And then all you're going to do is just plug in and subtract. So it's going to be e to the third minus e to the first. Can I combine it anymore?
Yes.
No. E to the third is just e cubed, whatever that number is, and then e to the first is whatever that number is. All right, let's try another one. And then I'm going to show you how to do that on my calculator. Okay, integral from 3 to 6 of dx over x. Dx over x looks kind of strange. So we're going to put that dx on the side. All right, what is the integral of 1 over x? It's a special integral, so you have to memorize it. Yes, very good, natural log. So this is natural log x evaluated from 3 to 6. So what you always do is you write that integral out first, straight line, and then write the limit. And then what you're going to do is top minus bottom. So natural log 6 minus natural log 3. Okay, whatever. Actually, this one we can combine further using the log rules. So log rule says if you have two logs with the same base and there's a minus in between, what can you do? Divide. Very good. So this is natural log 2. Okay, let's try another one. All right, now we're going to get into things that's a little bit trickier to do. This one. What should we do? Distribute? Yes, we should FOIL. Yeah, FOIL. That way we can take integral of each part by itself. Okay, so 0 to 1 of u squared minus u minus 6 du. All right, so the integral rule says we can integrate each one by itself, okay? But I'm just not going to write it that way. It's too much work. So you're just going to find the integral of this whole thing first, and then evaluate from 0 to 1. Okay, go ahead and find the integral of that. U squared minus u minus 6. Remember, you're taking integral of each one. Do you guys need help or you're okay? You're okay? Okay. Okay, let's look at the integral first. What is the integral of u squared minus u minus 6? 1/3 u cubed. Good. Okay, and then we're evaluating from 0 to 1. Okay, so we are going to plug 1 into the whole thing, and then minus, put 0 into the whole thing. Okay, so 1/3, 1 cubed, minus 1/2, 1 squared, minus 6 times 1, and then minus the entire thing. This one is not very interesting because it's 0, so you could skip it if you want, but you know, from this point on, it's probably not going to be 0. So I'm just going to show you how you would write this. So you're going to take evaluating it at 1 minus the entire thing evaluated at 0. Please be careful. For this one, it's not very interesting, but then later on when this is not a 0, you do have to subtract the entire thing. So put a really big parentheses around the whole thing and subtract it out. Okay, this is 1/3 minus 1/2 minus 6, which is
minus 6 to the 35.
Huh? 6 to the 35?
Oh, negative.
What?
Wait, no, negative 35 to the 6.
35 divided by 6.
Negative 35 over 6?
Yeah, over 6.
Okay. Negative 37 over 6. Yeah. Negative 6 and 1/6. Okay. So this is kind of what you do if the whole thing is, you know, two polynomials multiplied by each other. You kind of want to simplify that first. All right, let's try this one. This is a piecewise function. All right, just in case you weren't sure how to get started. So basically, this is a piecewise. It splits at pi over 2. So we're going to have to split this integral at pi over 2. So between 0 to pi over 2, this function is a sine x, and then from pi over 2 to pi, it's a cosine. Okay, so go ahead and evaluate that. Okay, so first take the integral. So the integral of sine x is negative cosine x, evaluated from 0 to pi over 2, plus the integral of cosine is just sine, evaluated from pi over 2 to pi. All right, so this is going to be negative cosine of pi over 2 minus cosine of 0. And the whole thing plus sine of pi minus sine of pi over 2. So this is cosine pi over 2 is 0. Cosine 0 is 1. Plus sine pi is 0. Minus, what did I do wrong? Oh, no, that's right. Sine of pi over 2 is 1. So it's 0. Okay, make sure you take integral. I know you guys are still kind of practicing for now, so you're like, oh, I sometimes forget to just take the integral. Okay, next. Word problem, but just, try to figure out that, this word problem is just asking me to find integral. Find the area of the region R bounded by the graph of y equals x squared, below by x-axis, and lying between the lines 0 and 1. Okay, so basically it's saying that you have this graph x squared. They want to find the area between this line, the x-axis, and the lines 0 and 1. Okay, so then how would you actually write a integral for this? Because area just means integral, right? So this is the integral of what? 0 to 1 of what? X squared. The x-axis is given because integral of any function from a limit to a limit is always bounded by x-axis. So we don't have to care about that. And don't forget your dx. Okay, so go ahead and evaluate this one. Okay, again, first find the integral, x cubed over 3, evaluated from 0 to 1. So this is just 1/3. Okay, any questions? Easy. Okay, so again, FCC has two parts. One is just saying that the area underneath the curve is another function itself, and then when you take the derivative, it's just that curve. Then second part is to find the integral, you take the integral function of the limit minus each other.